Hello everyone, my name is Tirth Sadaria, and on behalf of Shreya, I'll be explaining to you the Human Obstacle Detector and Tracker project for Acme Robotics, which is part of ENPM700 course. I'll go through the quad chart and explain you our project. The first part is objectives and overviews. So for this, we have to detect humans in real time. That can be also in a video or a photo. The second part is to track its movement if it's moving, and third part is to transform the human's position into a robot centric frame. And also, since it is a TDD module, we should have 90% or more code coverage on the project. Now let me explain you the approach and methodology for this project. Since it's a software development course, we are using agile iterative process for this, and also along with that we are using test driven development. And currently I'm the navigator for this project phase 0, and Shreya is the driver, and we'll switch the roles for the next phase. And we have also added CI/CD with GitHub and code coverage on the GitHub. The next part is technical details, and I'll explain. And as you can see here, we have listed the technologies and the softwares we are using for this program. There are 4 key algorithms for this project that we'll be using. The first is YOLO for human detection. The next one is IOU tracking, and that helps track the human if it's moving in the frame. The next is molecular depth estimation, or MIDAS, that is required for the 3D pose estimation of the human. And the last is to convert the human's pose into robot-centric frame. The next part is schedule and deliverables. So this is divided into 3 phases, and the first phase was designing UML and initial documentation. For the next part, we'll switch the roles, and we'll do the core implementation for the next phase. And for phase 3, we'll do integration and testing. You can also see the key deliverables listed over here for the project. Now let's go through the activity diagram to help us better understand how the code is supposed to work. So this is the activity diagram for our project, and as you can see, we start with the input video frame, and it's processed simultaneously in the 2 categories. First is YOLO interference and detecting the human in the video. Once we have successfully detected the human, we give it a unique ID and also track its movements in this part. The second simultaneous process which goes on is depth estimation, and using MIDAS or depth anything, we will generate a depth map for the image or the frame. And once we have the combined data for that, we get a bounding box and find the depth value at that point. Once we have the depth of the human, we convert its pose into robot centric pose, and after that we output its position either as an overlay to the video or just as a text file. The next part is documentation, and we have provided a proper documentation for this project on the GitHub repo, and I think you can find detailed instructions and steps which we have done in this process over here. Thank you so much.